Hey guys, welcome back to my channel. In this video I am going to explain the Excalidraw algorithm, which is you which is used to find the shortest path between the nodes in the graph. So this is a graph algorithm. So let me explain with the help of diagram. So for example, we have three nodes. We have three nodes. So this is node 0, this is node 1, and this is representing the node 2, and we have an undirected edge between the node 0 to 1 and 0 to 2, 2 to 1. So this is undirected edge. There is an undirected edge between every node. Every node we have been connected through undirected edge. So weight of this edge between 0 to 1 is 1, and that is 0 to 2, between 0 to 2, that is 6, between 2 to 1, that is 3. So in this Excalidraw algorithm is for finding the shortest path between the nodes of the graph. So this is widely used in cellular networks and GPS navigation systems and routing protocols. So this is single source path algorithm for finding the shortest path, and in this there is one disadvantage. If we have these known we have these we see, there is but there is one condition. We have these weights should be we have so these weights should be positive. These weight of edges between these two nodes should be always positive. If we have to find the shortest distance between any node by Excalidraw algorithm, then we have we should have the positive weight between these two between edges. So there is only one necessary condition, that is we should have positive weights. So let me explain this. So output for this will be, so for example, we have given source node. For example, in this example, let 2 is a source node. So we will take 2 as a source node. Then we will find the distance of every node from 2, that is from 2, distance between every node, distance of every node from 2, that is from 0 to 2, that is 0 to 2. What will be the distance? There are two paths from 0 to 2. So the first path will be from 0 to 2, that is the direct path, that has weight 6. And another path will be, first we have to go from 0 to 1, then we have to go 1 to 2. So the total weight will be, that will be 4. So this will be the shortest path. So the our output will be 4, and then from 2 to 1, the distance the weight between two from the weight between 2 to 1, that is 3, and from 2 to 2, that is 0. That is 0. because we have a same end node, and the starting node and end node will be 2 only. So the given so 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 there will be no weight, so there will be 0. So how to implement this Dijkstra algorithm? So there are two methods for implementing this. We will implement with the help of priority queue. We can implement this algorithm with the help of priority queue, that is PIRO, priority queue. And that is first method. Second method will be with the help of sets. So today I am going to explain with the help of sets. Then in next video I will explain with the priority queue. So let me explain it with the set. So at we will initialize the set with the pair that will contain distance, and node, that is this is source node, and this will be the distance from source node to that particular node. So we will take the pair, and let me write with the simple keyboard. So we will take the set as pair, the of name st. Let this name will be st. So the first integer will be representing the distance from the source node to that particular node. For example, source node to source node to node 1, there is a distance 3. So this is representing the 3, and this is representing the source node, that is 2. So next step is declaring, and next step is to declaring a vector that will contain our we can say that will contain our result distance, that is shortest distance between every node. So this vector will represent the shortest distance from the source node to the every particular node. Every node from the source node, this will contain the distance between every node to the source node. From source node to the every node, this vector will contain the shortest distance between source node to the every node. So we will name as result, and we will initialize this vector with the we have a number of vertices, that is nodes, number of vertices, that is number of nodes, and we will initialize this will to the max values. This because at the starting we are supposing that every node are unreachable, and they are far infinite. They are very far from each other. They are at infinite distance from each other. So we will initialize that with the int max. So we will initialize this vector with the infinity value. Then we note that the distance between source to source node, that will be 0. obviously that will be 0 from source node to source node, the distance will be 0. Then we have to push pair, that is 0 comma s is representing the source node. So we will push sorry we will insert this. Push is not any, will st dot insert will be there, you know, stl library in C++. There is a stl library, there is stl, so we will insert this pair to our set. Then we will run a while loop until our stack become empty, so we will run a while loop. What is happening there? What's wrong with this board? So in while loop we will store the address of the first iterator, that is it, that will be star of that begin, and then we will find the distance, that is it dot first, that is it dot first will, it is the iterator, and this iterator will it dot first, that we will initialize with the it we will initialize with the st dot begin, and this it dot first will give the distance, and it dot second, that will give the value of node, that is it dot second. It dot second will give the value of node, that particular node. Then we have to simply erase this as a node, that is it, and now we will check the adjacent node of that particular node when we are encountering that node. So simply we'll take the iterator, adjoin of node, we'll take int node, that will be vector of 0, and int weight, that is vector of 1, and then we will check the condition. If our distance plus weight, that is less than our resultant adjacent node, then simply we have to store this result of adjacent to d plus wt. Then we have to simply insert this, d plus wt comma adjoin of node. So at the end we have to simply return that resultant vector. So this is the code for the Dijkstra algorithm. So let me explain with the documentation, that is A to Z driver sheet.